how we're going to try to classify the 4 soil samples as per the soil texture, soil triangle. So what do we have here? This is sample number 1. This is stuff I got from around here. And so this one is a garden mix that I made, and I used to grow all kinds of stuff in this little garden patch in my backyard until I finally said the birds and the rabbits could just have it, you know, because they ate it all before I had a chance to eat it. But that's some garden mix soil right there from my backyard. Over here, grab places in the shade. I mean, try to keep yourself in the shade as much as possible. I'm going to bring these over here where everybody's close. That's okay. This is soil sample number 2, and it's also from an area in my yard that gets periodic floodwaters coursing over it from a hillside right behind it. And so you can see that the soil texture is finer, has more silt and clay in it because of the runoff from the stormwater. Soil sample number 3 is also from an area that's closer to the mountain behind my house, and it's got more little pieces of gravel in it and coarse sand. Just from eyeballing it, you can tell that, right? Remember when I said that the closer you get to the source, you know, the mountain, the larger the particles are likely to be. It's kind of a general rule of thumb. Well, unfortunately, I don't have another lid, so we'll just have to sweep off the bench here. I'm going to get a corner so I can sweep it off and try not to get it all over Chris's feet. This one is an agricultural soil that I got right over just south of the flight line here. If you go down to Sossaman Road, right outside the campus, and drive south on Sossaman until you get past the airport, you'll see the radar dome. I don't know if anybody's seen that radar dome.
Golf ball.
Yeah, that looks like a golf ball. And so just to the east of that, on the east side of Sossaman, there's an agricultural field. And it had cotton or alfalfa or something like that growing in it last time I saw it, but it was fallow yesterday when I went and got that soil sample. So this is agricultural soil from right around here. Now that looks like it might be a rock, but it's not. This has got a lot of clay in it, and it's trying to cement itself together. Once, especially the clay-like desert soils that we have around here drying out, then there's a tendency for the salts that are associated with them to cause like a cementation, so the particles are getting stuck together. And when you do your drilling, you'll run into into layers that we call caliche, C-A-L-I-C-H-E. It's really white color stuff because it's got a lot of salts dissolved in it. And it's a precipitation of salts into a soil lens or a zone underneath the surface. And sometimes they're only about an inch thick, sometimes they're about a foot thick, but it's like cement, trying to hammer through that, dig through that, or drill through that. It's naturally occurring cement, basically, is what it is. But this has not turned into caliche. It has the potential to turn into caliche. So what else do I have here? This is kind of another one of those quick, non-scientific test that you can do yourself pretty easily. So this is a sample of number one. This is number one in a column of water. One, as you recall, looks like this. It has chunks of rock in there that I intentionally put in to help with the aeration so that I could grow plants in it. It has some organic material mixed in there. It's got a lot of sand and not so much silt and clay. And when you put it in a jug of water and shake it up and then let it settle out, this was this morning when I did this. So we'll pass it around. You'll see that at the top it's got that organic material floating. And then the next layer down is clay that is still in suspension in the column of water because there's a high opacity. That's probably about, if I hold this up to the sun, I'm estimating the opacity on that is more than 50%. It's muddy water, basically. So it's got a lot of clay still in suspension there. And then right at the top, where the solids have actually made their way to the bottom due to gravity, you see the silts, and then the fine sands, and then the medium and the coarse sands, and maybe even a chunk of rock or two at the bottom. Remember what I said in the classroom, that the heavier ones fall to the bottom first. Bigger, larger, heavier particles fall to the bottom first. And they don't travel as far. Okay, so here's sample number 3. You can see the difference in opacity of the water column above the layers of sediment in there. So number 3 is this one. It has a lot more gravel in it. Pebbles, gravel, a lot more coarse sand, and a lot less silt. A little bit of organic material floating, some clay in suspension there, and then you can see the silt layer and a lot of coarse gravels and sands. Try not to shake it up too much when you pass it around so you can preserve the profiles that formed at the bottom of the jugs. I only did 2 of those things, but you could probably, if anybody wants to take my jugs and the soil home with them tonight, you're welcome to, so I don't have to carry them around anymore. And you can do some experiments with them yourself and play around with them. What else do I have? I think we're just going to go to the scale next and the sieves. So any questions about this before I move to the next part of the demonstration? Well, how are we doing for time? Oh, Emma has a question.
Well, I was just wondering, it looks like the silt is all gathered on one side of the jug. If there was any reason for that, or just...
Probably because of the way I was driving over here this morning. I was making really sharp turns, The jug probably got tilted on its side in the back of my car. That's my guess. Because I shook it up in my house in the morning, the kitchen, made a heck of a mess of the kitchen sink, and loaded all the stuff in the car and drove to work, so it probably got sideways in the car a little bit. That's my guess. We can shake them up now and see what happens. You want to do that? Everybody's seen what they look like after they've had several hours to settle out. That's an interesting observation, though. I can't think of any other explanation for that side. You want to show the question that Emma brought up? See how there's a slope there? So that jug was probably like this in the back of my car as I was driving in this morning. If you guys want to move in the shade over there, be my guest. There's no need to keep yourself parked in the sun. Feel free to move around anywhere you want. So it looks kind of like chocolate milk. See what happens to it after a few minutes. Chocolate milk. Dark chocolate. Extra cocoa. Ming Ming's not here. I don't see Ming Ming. But she's doing the experiment on the heavy metals and chocolate, right? You want to leave some headspace in the jug so that you can get the agitation necessary to mix it up good before you let it start settling out. But it doesn't take long for the heavy stuff to fall to the bottom. You can already see the profile for the heavy stuff, the gravels and coarse sands. Didn't take long for those guys to accumulate. All right, how are we doing for time? 3:35. I think we're going to be okay. So what you see here are sieves. I call them a sieve stack that I've used in the past to do air pollution control work. Maricopa County Air Quality Department has a rule called Rule 310, and there's also another rule called 310.01, which governs the amount of silt on unpaved roads, unpaved parking lots, vacant lots, open areas, so that we can control our PM10 air pollution in the greater Phoenix area. There's the Rule 310 and 310.01 took an ASTM test method for soil and adapted to make it more specific for our PM10 dust control purposes. And so the sieve sizes are specified for the Maricopa County Air Quality Rules 310 and 310.01, not for the purposes of a soil texture triangle. But that's all I have that I can use to demonstrate for you today, and we can make some extrapolations to come up with some quick and dirty estimates of how you would characterize those 4 samples with these sieves. Yes, Chris?
You said the sieves were adapted for the air quality control testing that you're going to use basically just to find out what size particles are actually settling from the air onto the ground.
Okay, so the PM10 is inhalable dust particles. So we're talking the clays and the silts that can get into our lungs and cause health problems. And that's what's regulated by the Clean Air. But the soil texture triangle is not designed to, help us figure out the compliance with the
No, I get that. But you had said that these sieves were adapted for the Clean Air Act testing that you're doing.
Yeah, that's the purpose of why I purchased these sieves.
Strictly to find out what
PM10
size particles we're actually collecting. So we actually have to take samples off the ground that was collected.
Yeah, I have some samples I collected from unpaved parking lots and unpaved roads in my kit, which I demonstrate to the students when we do the pollution control plans. But for the purpose of today's demonstration, it's just to help you figure out the soil sizes and classify soils per the soil triangle. So the smallest sieve that I have here is 0.25 millimeters, which means that according to the Maricopa County Air Quality Department definition, anything that passes through this bottom sieve is classified as silt and clay. It's going to be both silt and clay. So it's going to, everything that's below this point, I'm going to get a picture of the number there. This is ASTM sieve number 60.25 millimeters. And so whatever is able to pass through this bottom sieve and the sieve stack, get into this collector can on the bottom, that's going to be silt and clay, a mixture of silt and clay. For the purpose of helping us figure out that soil texture triangle, we're going to make a non-scientific assumption. Because this is just a demonstration here, and we're going to make an assumption that it's 50% silt, 50% clay. So whatever makes it through all the way to the bottom from each of those 4 samples, we'll weigh it out, and that'll be our clay and silt. We'll just say 50% of it is silt, 50% of it is clay. Does that make sense? Because I don't have a sieve size for silt, or for clay. Sorry. I don't have a small one to get us all the way down to this place. Yeah? I don't have it. Okay. Now, we build the stack of sieves. Next one is 0.5, sieve number 35, ASTM sieve number 35. Then the next one is sieve number 18, sieve ASTM 18, which has an opening of 1 millimeter. And then we go to sieve number 10, which has an opening of 2 millimeters. And then we've got the coarsest one on the top. If you're going to be doing this for regulatory purposes, you want to get rid of all these old particles from the previous sample. We're not going to do a regulation enforcement here today. This is just a classroom demonstration. So the top is a 4 millimeter sieve set. And then there's the lid. So you've got to have a scale, you've got to have it on a level surface. Let's get sample number 1 over here. I think I'm just going to use my hands. I have a jug of water over there. So you want to tare your scale. You have it in ounces. So the plastic weighs about 5.4 ounces. Hit the tare, and now it's reading 0. And so whatever I pour in here is going to be the sample mass. Just for the sake of this demonstration, we're going to try to get about a pound. So what's that, 16 ounces? We're up to 10.5. I also brought along a PM10 mask, an N95 mask. Everybody really thinks they need it. A little over a pound. I went over a pound. I think it's close enough. Almost found it. There we go. So it's right on a pound. Okay, so now we have a sample, about a pound here. I'm going to just turn this off. Dumping it in here. Try not to breathe the dust. Maricopa County Air Quality Department Rule 310 and 310.01 specifies 1 minute of shaking sideways vigorously and up and down vigorously for the unpaved parking lots and unpaved roads. But I imagine if you were going to do this for the purposes of soil integrity or soil classification, you want to go look up the ASTM method for that and find out exactly how long you're supposed to shake it and what the directions are. Also, in the laboratory, they have shakers to help you do this automatically so you don't have to work in the sweat. Right. Has anybody been timing me? Okay, it's been 30 seconds? Okay. Let's count it down. How many when
25.
Sweat. I'm starting to sweat.
20 seconds.
Let's make it 10. Is that good enough? Close enough?
10 seconds.
Nice enough for ASU 523? So we'll get them all out here so you can see. So these are all basically gravel, pebbles. Here it looks like it's still more gravel. This maybe is starting to get into some coarse sand. Maybe some medium, that would be like a medium sand, a fine sand. And this is your mixture of silt and clay. 50% silt, 50% clay is what we're going to assume. We don't really know if it's 50-50, but for the purposes of this demonstration, we're going to say that one's 50% clay, 50% silt, right? So, for the purpose of making this classification, we only have to count up to here, because all the rest of it is sand gravel according to the soil triangle, right? And I would like to abbreviate this by just making we'll just measure this, just weigh this. We already know that all the rest of them are a pound, so we'll subtract whatever this is. A pound. Does that make sense? Okay. So we don't have to weigh each one of these individually. But because of the soil weight, the soil triangle is written. Okay. That one is carrying at 0. So you want to try to carefully shake this in here so you're not losing any of your sample. .8 ounces. So 16 minus 2.8 ounces.
13.2.
Okay, now write that down on your clipboard, on your pieces of paper there. 15.2, yeah?
13.2.
13.2, okay, good. And now we want to divide that in half, because 50% of it is silt and 50% of it is clay. So what's that number divided by? What was that? I should be writing all this stuff down.
2.8 that we're dividing into, because that's, so that's just 1.4.
The total weight is 16 ounces, right?
So it's 1.4 clay, 1.4 silt, and 13.2 sand.
1.4 ounce clay, 1.4 ounce silt. How much sand?
13.2.
Okay. So you would divide 1.4 and then divide that by 16, right? To get the percentage of clay. Am I correct?
Yeah.
Okay, what is that number? What's 1.4 divided by 16?
0.087.
8.7%.
It's 8.7%.
Yeah.
8.75,
Let's-
so 8.8.
We can round it to 9%. And we're dividing it by, so let's just say they're both 9%, because that's, so we got two 9%. Get your soil triangles out and draw the lines. Got 9% clay. I guess 10% is the closest number on that thing that you can find. Draw your lines together. So you got 10% silt, 10%.
It's right on the border between sandy loam and loamy sand.
90% sand, if I'm correct. Right? If we're going to make that assumption. So, Emma, you're saying it's where?
Border between sandy loam and loamy sand.
Sandy loam and loamy sand, yeah. Maybe 10 is 10.
Oh, sorry, I was looking at the wrong way.
Sand and lime.
It's just sand. You're right.
I'm saying the intersection is down at the. It's pretty close to where the loamy sand starts, so it's in between. I would accept your interpretation. Let's say then that the sample number 1 is a sandy loam / loamy sand. That's a pretty good description of what we have there in sample number 1. Would everybody agree? All right, let's go do sample number 2. Put everything back into my group. Now I'm going to ask for volunteers here to go ahead and weigh out the next sample. Who wants to? I brought gloves, and you don't want to get your hands dirty.
Luke volunteered himself.
So I said in class, you guys want to get your hands dirty? You want to get down and dirty? And I had everybody was going, yeah.
I don't remember ever being that enthusiastic about it.
Well, come on, now your chance. And just remember to wash your hands before you have another trip.
Soil 4. What? Soil sample 4.
Number 4. You want to do soil sample 4?
Want to do soil sample?
We're going to jump all the way up to 4. We don't have to do all of them if we run out of time. And what time is it? 3:50. Okay, so yeah, we have about 20 minutes, I guess. So Luke is just carrying the scale. You got it to 0? Yep. All right. He doesn't want gloves. He likes to have the bare hands. Now, you know what I would recommend you do on this one, Luke? You pick the hard sample, because those are chunks of clay that are all cemented together. Yeah. Break them up. Yeah, I break them up. Just get rid of them. That's probably the easier thing. Just get rid of the big chunks and grab mostly small chunks in there. So you don't have to go through the crushing process. But those things, if they can be crushed, they need to be crushed first in order to classify this soil properly. What you don't want to assume they're rocks or sand, right? Because if they are actually crushable, they're probably silt and clay. And they need to be measured. Does that make sense? Yeah. So what are we up to? You're up to 11 something?
13.3.
And once again, there's laboratory equipment that will mill these samples up for you. Crush up those balls of clay that form.
That's pretty good right there.
You're close to, yeah, you got it. You got a pound. Try to crush up some of those. These are smaller pieces. Now leave it in there. You don't want to throw it away because you already counted it. This parent material for this soil is probably the Santan Mountains. If you look to the south, when you get out of the campus area, there's a mountain range called the Santan Mountains. That's mostly a volcanic, igneous material made out of rhyolite and velvet tuff. So there's a lot of volcanic ash associated with it, and ash is very fine material that could result in clay when it erodes. Think about in air pollution control, one of the biggest, most concerning emissions from combustion, fossil fuels, is PM 2.5. It's a very, very small particulate matter. And so, a lot of this is derived from volcanic activity. You don't want to get it any more crushed up than that? You gonna call it close enough for ERM523?
I think so.
Okay. Who's going after Luke? Who wants to get a chance to do this today?
I thought Luke was having such a full process.
One minute. Who's got their watch?
I'm gonna start right here. And go.
Should we sing a rock and roll song for him? Get into that shaking. You're gonna be rocking and rolling for us, Luke.
I'm good with my own rhythm.
He's got the rhythm.
Can't stir it. It's either can't stir it. One way or
That's right. It's up and down or
One axis.
sideways. Up and down and
one
sideways.
axis direct. Throw it out then.
30 more seconds.
Almost there.
Almost. 15 more seconds.
Huh?
15 more seconds. And 10. 5. And you're done.
Right. So, in order to accelerate the determination of the sample, we'll just weigh the bottom collector. Look at all these things that they could be crushed that we're not counting. And see, those are still crushable. So I think that's an underestimate of what we're actually going to classify this as. But we don't have time to crush them all up. Most of these things are also crushable. See how they're crushing in my hands here? You wanted to spend the time, we could sit here and crush all this stuff up. But I think you get the idea, right? So is Emma going to be our statistician again on this?
Sorry.
Write down all-
5.9 ounces.
And we divide that by 2. What have we got? That's rounded off to 6.
All right. 6.
3 ounces and 3 ounces. And you?
Got all that in there.
Yeah. I really thought it'd be a lot higher than that. So 3 divided by 16. What's that in percentage?
It's 19%. So we'll round that up to 20.
So we're going to round that up to 20. We got 20% silt, 20% of clay, and 60% sand. Right? Is that how that works out? So we get our soil triangle out, and we go 20% clay, and what did I say? 60% sand and 20% clay. Or rather silt, and let's start drawing the lines together towards each other.
Sandy clay loam / sandy loam.
Sample number 4 is going to be, say that again?
It's right on the border between sandy clay loam and just sandy loam.
Now because we have underestimated the salts and the clays, I would want to call it more towards the sandy clay loam. That's how I would classify this one, because we know that we could spend a lot of time crushing this stuff up and get a lot more silt and clay. Feel free to move over and get in the shade. Need to see anybody suffering over this. So we're going to classify this as a sandy clay. You want to do another one, or where
Adam's up.
How much time we have?
It's 4 o'clock.
Oh, yeah, 4 o'clock. Okay, so we could do one more. Who wants to get their hands?
Adam wants to get his hands dirty.
And one more, and then I have a final, really quick and dirty test to show you. After that, which one do you want to do?
What's the quick and dirty?
Number 3.
Yeah, the number 3.
Okay. Start working on it. You want to weigh out a pound of that stuff.
Yeah.
And I'll get rid of these. Compare the. Thank you. You charge the scale first, right? Okay, good.
Oh, boom, on money. Good to go.
Starting out with 16 ounces. Sure they're stacked in the right order. Yep, got them.
Nope.
I don't think you have the proper shoe wear. You got open-toed shoes.
I told Luke I didn't have the proper PPE. I can't be doing this.
You know, so
He signed a waiver.
you better not hurt your toes here. Don't drop that zip tag on your toes. Go for it, man. Go for it. Moving and shaking. Got the time.
50 seconds.
2 seconds left. Giant martini shaker. Those are some big strokes, you know. Sideways too. This is where some good sturdy boots. It's pretty sturdy. And 60 seconds, right? How many more seconds?
30 seconds remaining.
Still 30 seconds. Keep on.
I thought we got it's good enough for ERM, but I'm tired.
Give it a vigorous shake. Vigorous shake. There you go. Make that stuff rattle and shake like a tambourine. Make it sound like a tambourine.
You're good.
Clap him down to the last 10 seconds. Oh, got it down. Okay. See how they all sorted out. Another thing you want to check for is down in the collector pan, got hardly a thing. Let's get Tile. Get a good view of this with the camera, so you can show the students online.
Really nothing much.
There's not much of any silt and clay left in here. So it's almost all sand and gravel. Yep.
You're still gonna weigh it?
Yes, sir.
Just make sure you tear first.
Always.
Ground cinnamon.
Looks like ground cinnamon, huh?
0.4 ounces.
Not even an ounce. Not even an ounce. Wow. Okay.
That's 0.2 of each.
0.2 of each.
So 0.2 divided by 16. 0.01%. I mean 1%.
So we're gonna say only 1%.
Yeah.
1%, 1%, and 98% sand. So that's gonna be an easy one for us to
It's
classify. It's basically sand. So yeah, because this chart does not get us down to 1%. So it's in the sand. So sample number, what was that number? 2?
3.
3? Number 3 is classified as sand. Now, you probably would want to say sand and gravel, because that's clearly gravel. So I would add the word gravel, or sand and gravel, to my driller's log. That's how I would write it into the driller's log, sand and gravel. Okay, one more thing I wanted to show you, unless you want to do another sample.
Let's show us quick and dirty.
Okay, so for this last test, it's not scientific, but the drillers do it all the time. The drillers do it all the time. I stood side by side next to a drill rig, watching the drill bit go down and watching what's going on and everything. And I know these guys do it. So this was the sample we just had, which was mostly sand. We want to try to get this saturated with water. Just a handful of the dirt. If somebody wants to pour for me, they're welcome.
I got you out.
So because we want to saturate this. Have you ever mixed up like mortar for a tile job? You know how you're trying to.
Just let me know when you.
Yeah, I think it's saturated. Right? Okay. So now you want to see if you can make it roll into a string, and if it holds together when you hang it upside down as a string, that's a sign that it's got a lot of clay in it. I didn't get any notion that there was clay in this sample number 3, which we classified as sand. That isn't it. So we can do the next one. Okay, I don't want to contaminate the next sample. Okay, this one's my garden soil. I think this was my garden soil.
Your special mix.
Yeah. So go ahead and let's try to get that saturated. That's good. That's good. Fourth. A little bit more. Pour slower. It's like when you're mixing up grout, you don't want to put too much water in it, otherwise it won't hold. So I got it saturated. Let's see if I can turn it into a ball that'll hold together or a string that'll hold together. Now, what did we classify number 1 as? Is that number sandy loam? We classified it as a sandy loam, right? So not much clay in that one. Okay. This one's number 2. So this is. Do I have a question?
No.
No.
I was just saying we'll try that.
This one, I don't think we did we didn't weigh this one out, did we? This is sample number 2. This one's the one that is at the base of the hill where the floodwaters have deposited this material. That's slowly, a little bit at a time, a little bit at a time. A little bit at a time. I think that's right. I think we got it.
Sure looks funny.
Catch. Catch. Okay. I'm going to try to make it roll into a strip of clay, into a, like we're playing with Play-Doh. You ever play with Play-Doh? It's not. Maybe if I had a smaller sample, I might be able to get it to hold together. It's getting there. I mean, it's almost. You can tell there's some clay in this. It's holding together. Look at it. I think that's got some clay in it. So this is predominantly silted clay. If we were to do the measurement, I think we would be classifying it more like a clay loam, a sandy clay, a silty clay loam maybe. Okay. One more. This next sample is going to be the agricultural sample. That's the agricultural sample.
Yep.
It would be best to try to get the smallest pieces and separate out the big chunks. Remember how when we did the analysis, we came to the conclusion that even these chunks can be crushed. So let's try to get rid of as many of these chunks as possible. Okay. Oh, wait. pick out a few of those chunks. Get rid of some of those chunks. Okay. See how we can put just a little bit of water at a time. A bit more. Just imagine you're mixing up mortar for a tile job. You don't want to get too much water to where you're washing it. You don't want to wash the clay out of your hand. Right? You want to keep it. The water a little bit. Might have put a little bit too much water. We got too much water. Session. So I'm going to work this a little bit. Squeeze it between the fingers. See that? So I'm crushing up the solid chunks. I think I should have worn gloves. I lost almost all of it. Yeah, that's too wet.
Sticking to your hand.
It's too wet. Yeah, so we need to try to continue to bring it more like the texture of a mortar. All right. If I worked it for a few more minutes, I think I would probably be able to get it just where I want it, but I know we're about out of time. So I'm just going to roll it here into that string. And the more you can get it to turn into a string that looks like Play-Doh, the more you can say this is clay. It's holding together really nice, isn't it? Try? Yeah? Okay. Yeah, look at that. That thing is just, it's getting longer and longer and longer. I mean, that's got a lot of clay in it. Seriously. This is what the drillers do. I know. It looks really weird and dirty, but I mean, that thing's got a lot of clay in it compared to that first sample. Remember that first sample? It just totally fell apart. So did we give this one a classification?
Yeah.
A sandy?
Plain loam.
Sandy clay. And we said it was how much percent clay? 20% clay?
Yeah.
You'd think it would have more. I think it would, because we didn't crush up our original sample to get all the, to get it into fine particles. We would have gotten a higher percentage of clay on it. Based on the weight in the hand, using this hand test. Okay. Oops. Oops. Get an extra cookie, I'm sorry. How bad was it? Just a little. I'm sorry. Okay, are we done for the day?
Yeah.
Before I can do any more damage, I'm gonna sign off.